Warning, the video you're about to watch contains mathematics at the level of precalculus. All material has an assumed prerequisite of college algebra and trigonometry. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, Professor of Mathematics at Cosumnes River College in Sacramento, California. This video is meant as a review of concepts from your trigonometry class. So as such, I do not delve into the proofs of theorems, nor do I go into excruciating detail with examples. If you have never had a full course in trigonometry and you are currently enrolled in a pre-calculus course, I highly recommend watching my trigonometry playlist on YouTube, as it goes into greater detail with all of trigonometry. Again, trig is so important for calculus that having a shaky background in the subject will lead to abysmal results in your future courses. All right, let's get into this here. Review of trig functions, the right triangle approach. This is actually what I consider to be the best approach for trigonometric functions, at least from a trig kind of perspective. When you get into calculus, the unit circle approach is actually a lot better, I think. But an introductory approach, the right triangle trig, is awesome. So the right triangle trig approach, you have a right triangle, right? And you have an angle. I'm going to call that theta instead of t. So we'll just do that. And you want to know all the trig functions based upon that angle. Well, they're based upon the sides that are in relation to that angle. So the side that, as long as we agree, the sides of the triangle are called opposite and adjacent, and the hypotenuse is not a side, it's the hypotenuse. Then the side that's adjacent to theta we'll call adjacent. Obviously, that's the hypotenuse. The side opposite to theta will be called opposite. So opposite and adjacent change perspective when you move the angle. So if I was looking at this angle, alpha, then opposite that angle would be here, and adjacent that angle would be there. It's kind of important to note. Anyhow, so the trig definitions are here. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. And then you have the reciprocal functions. And we've already covered these in a previous video, but still. Cosecant, which is the reciprocal of the sine. Cosecant of theta is hypotenuse over opposite. Secant of theta, which is the reciprocal of the cosine of theta, is hypotenuse over adjacent. And finally, cotangent of theta, which is the reciprocal of the tangent, is adjacent over opposite. That is all you pretty much need to know about the review for trig functions, but let's go ahead and just use them once in this video for an example. Again, the assumption is that you have seen all of trig already, so it might have been a year or two, and you just need to remember how this stuff works. So here we have a very complex, actually I call this a compound geometric figure. You have this black triangle, which is a right triangle, and it's perpendicular to the ground. And you have like a shadow of a triangle, this red triangle, that's actually on the ground. They are perpendicular to each other, or orthogonal to each other. Let's see, angle ABD. This is a good review of what that notation means, by the way. If somebody hands you a notation, angle ABD, like that, the central letter there is the vertex of the angle. So the vertex being B, but we had to say angle ABD because B is actually the vertex of two angles. But this angle right here, I'll draw it in black. That angle is 53 degrees. So I'll just put that in there. And let's see, what else did they give us? That angle C, there's no need for angle C to be referenced as BCA or something like that, because it's not really attached to any other triangle. So this angle that's on the floor right there, they give us as 48 degrees. So I'll write that in there, 48 degrees. Always very important to label things out. And then side length B to C is 42. And we're tasked with finding X, and H. I'm going to do what I did in the previous video. If you're watching these videos in order, I'm going to break this three-dimensional figure into two-dimensional figures. So there I have broken it into two pieces. Notice that I do a little color coding here. So the black triangle, this guy right here, the side H, side X, and the angle 53 degrees, is this triangle right here. Notice that I have color-coded that horizontal length X as blue. And the reason why I do that is because that is the shared side between these two triangles. They both share the side length X. And so when I drew the triangle that's on the floor here, which is with the 42 side length, the X side length, and the 48 degrees, I also have that side length, that shared side length X as blue. By the way, these angles are accurate. So that's actually a 48 degree angle, and that's a 53 degree angle. I just thought I'd tell you that. Anyhow, so the reason why I do this, break it apart into two pieces, is because I see I have a triangle with one missing piece versus a triangle with two missing pieces. The one with the one missing piece is actually much easier to start with, because you can, given a couple pieces of information in a triangle, you can find everything else. So I can find that missing piece. I just need to know what trig function relates this angle right here to these two sides. And that's a common question from your trigonometry course. So important that I decided to write it down. What trig function relates the given information, 48 degrees and side length 42, to the unknown, the X? And we can see that that 48 degrees, its opposite is X, and its adjacent is 42. And if we look back at our trig functions, opposite and adjacent are associated with the tangent. Yes, they're associated with the cotangent as well, but generally speaking, I like to stick to these top three choices, or the first three choices: the sine, the cosine, and the tangent. So the tangent is opposite over adjacent. Therefore, we know that the tangent of 48 degrees must be X over 42. Or in other words, 42 times tangent of 48 degrees must equal X. Now, something that I tell my students is that this is called exact form. In other words, we have not grabbed a calculator, and it's good to leave it in exact form for the time being. We do not want to round that yet, because we're about to use it actually. So I'm going to go over to the second triangle. Now that we know what X is, we know this value of X is 42 tangent of 48 degrees. We now need to relate the known information in this triangle to the unknown information. And the known information is 53 degrees and X, and the unknown information is H. And what trig function relates 53 degrees to this opposite and this adjacent? And again, it's going to be the tangent. It will not always be that way, but in this case it is. So we know that the tangent of 53 degrees is equal to H over X, opposite over adjacent. Multiplying both sides by X so that we can find out what H is, we find that H is equal to X tangent of 53 degrees. Or in other words, H is equal to, let's see, X is 42 tangent of 48 degrees, and then we're multiplying that by the tangent of 53 degrees, and that is what H is. And then at this point, you can go ahead and grab a calculator to figure out what these values are. I highly recommend that you pay attention to the mode that you're working in. What do I mean by the mode that you're working in? Well, you can see here I'm on Desmos' scientific calculator. It's under their math tools, scientific calculator here. And if you look at these buttons here, you have a degree mode and you have a radian mode. The one that's highlighted or lit up is the mode that you're in. So for example, we know the sine of 30 degrees should be a half, and it sure is. If we were in radian mode, sine of 30 radians definitely is not a half. So that's just an important point to make here. We knew that x was equal to 42 tangent of 48, and again we're in degree mode here, so x in this case is 46 point let's just round it to single decimal place, 46.6, and then h was equal to that x value times the tangent of 53. Notice how I'm using Desmos's ability to save variables just to save me a little bit of time. So this tells us that h, the height of that the triangle, is 61.9, and I didn't really give you units for the length, so it doesn't really matter what the units are, but 46.6 and 61.9. And there you have it right there. All right, that rounds out this video, and I hope that helps. If it didn't, please watch my full video series on trigonometry.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way. Cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close. Don't talk too much, that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.